Hello, everybody. Welcome to Physics of the Universe. If you're getting this video, that means I am not here today. I was going to be gone on Tuesday and Wednesday of this week. So this video is really here. I put a link in Canvas for it for you guys to get a better understanding what to be doing on today's assignment, because there's a couple things that are kind of complicated, and I'm not sure if there's anybody that's experienced enough to know how to do some parts. So this video is going to be kind of helpful for helping you guys get the assignment that's due the day that the substitute's here. So first and foremost, of course, you guys are going to need to get on the computer. You guys are going to need to get onto Canvas, and then of course you'll need to get onto our page. So I'm already here. I'm just going to move this picture of me because I'm not important to this assignment. I'm just going to make it really small. And we're going to click on, this is Physics of the Universe, right? So we're going to click on Physics of the Universe. There it is. You're going to click on Physics of the Universe. And of course, as always, remember, if you're ever absent, this is what you want to look for. This is the days, what we've done for every day. So there's the date is right there. That's what our schedule is. So on the 2nd or 3rd of next week, that's Tuesday or Wednesday, you might be in my red day. That's an advisory day. There's the assignment right there. You're the gold day, which is a regular day. So you guys will have a little bit more time to do this. You guys need to click on where it says Expanding Galaxies. It doesn't matter which one I click on. Both days are the same thing. You guys are both doing the same thing, both classes. So you guys are going to click on the assignment. I don't have any notes for this right here. I will probably add this video to the notes section a little later. Class flow, basically just telling you that this is what the assignment is. But this is the assignment right here. You want to click on this right here. It says Galaxy, Mini-Lab Galaxies. The first thing you guys need to know before I go any further into this is that the universe, if I didn't get a chance to talk to you about this in the class before, the universe is big. It's really big. The universe really encompasses everything that we can see or perceive, period. So looking off into space, all the stars, all the planets, as far as we can see, as far as our knowledge reaches, that's what we refer to as the universe. Now, our sun, as many of you guys already know, our sun is a star. So when you're looking up at the night sky, what you're seeing is other stars that are just like our suns. They might have planets. They may or may not have planets. Some stars have other stars that are going around them like they were a planet. And we are just one solar system of literally billions of solar systems that are all gravitationally bound together in this great big complex of stars, swirling mass of stars called the Milky Way galaxy. So we live in a place called the Milky Way galaxy. And our Milky Way galaxy, once again, is just made up of billions of stars all swirling around. Looks like a giant hurricane, really, of stars all orbiting around the center. Beyond our Milky Way galaxy, the universe goes on. Aside from our Milky Way galaxy, there are other galaxies, each of those galaxies containing billions of stars. Some of them are relatively close to us, which might cause our galaxies to actually come together due to gravity. But most of the galaxies in the night skies, almost all of them, when we look up at them, we know that they're a collection of billions of stars, but we can also see that they're moving. And what's really kind of strange about their movement is that every galaxy that is not affected by our gravity. Every galaxy that we perceive, and there's trillions of galaxies out there, every one of those galaxies are moving away from us. And the further they are away from us, the faster they're moving away from us. And this is going to be an important concept to this class, because a little later on in this class, this is called physics of the universe. We're going to be starting to talk about the universe a little bit later on, and we're going to get into the details as to how we know these galaxies are moving, and how we know, or why, I'm sorry, why those galaxies are moving away from us. But that's not important right now. What's important right now is for us to realize that those galaxies that are already really far away from us, I mean, they're so far away from us when they're looking at us, the amount of time it took the light to leave our galaxy to reach some of these other galaxies, if they were looking at the planet Earth, the light that came from the planet Earth right now, they wouldn't see humans and buildings and roads and stuff like that. What they would be seeing is dinosaurs and swamps and things like that. They're so far away that it almost looks like you're looking back in time when you're seeing them. So here is the lab that you guys are going to be working on. It's called the Speeding Galaxies. And when you open this up, first of all, when you open up with this mini lab and you don't get this screen right here, it may be a blank screen and it might be telling you to authorize. Oh, this is always a fun thing. It's just you have to scroll down a little bit. There'll be a little button right here at the bottom that says authorize. And you click that little button that says authorize, then you can log into, it's going to ask you to log into your school Google account. Then you'll be able to do this. So here's the lab. And basically what you're going to be doing is there's links in here. You need to read the instructions in there. Of course, put your name in there. There's videos. If you click on the videos, there's helpful videos for you to watch. There's a data table. This looks very similar to the data tables that you guys were doing with the pendulum experiment and the ball on the floor experiment. You're going to take this data table, which shows you the distance, how far the other galaxies are, and what's called a megaparsec. Um, for now, just think that megaparsecs are really far away. A megaparsec, and how fast that galaxy is moving. So we're looking at how far it is away from us and how fast they're moving. All right. Now, if this is too small and you're like, oh, Mr. Lee, I don't want to, this is just not enough room. I can't get around. I want to have this full screen. If you just click right here where it says Mini Lab Galaxies, it will open up another whole screen that looks like this. So you're using Google Docs. But what's kind of cool about it is if you're using it in Canvas like this, you can hit submit and then your assignments automatically submit it and I can see it. You need to hit submit at the end of the period, finished or not. You have until when I grade these to get it done. But just because you hit submit doesn't mean you can't come back and work on it more later. So go ahead, just make sure you save your project process by hitting submit. And you can go back and forth between these two things and hit submit and then go and work on it and come back on it and hit submit. So here is the main lab right here. I've made a copy of it for now. And let's say I needed to go through, it's telling me to go to Desmos and create a graph like this. So at the top of your browser right here, you have what's called tabs. So part 2, it says, use Desmos, this link right here, use that one to graph a best fit line. So you got to go to this Desmos right here, and it's going to open up a pre-made Desmos things, especially for this lab. And what we're going to have right here is the distance of the galaxies in megaparsecs. And on the other side, we're going to have the speed in which they're moving away. So this D stands for distance, S stands for speed. So I know the distances were like 1, 2.5. I don't know what they were. You're going to have to actually figure out what they actually are. 3.0. And I think it was something, those probably like 300, 600, 800. Those aren't the actual numbers, so don't write exactly what I write. Now, just put the numbers, don't put the units, just put the numbers on there. And you can see I have data. I probably shouldn't have gone 30. Probably should have said 7 or something like that, because I think the highest is 10. There we go. So from there, here we've got some data points. And your data points, since I just put some arbitrary numbers here, it's probably not going to match up that great. So hopefully your data points will have a better trend in mind. But how do we match this up? Remember, we go here to the C, which is a constant that tells us what the line looks like and the slope of that line. And we're going to slide this back and forth until that line best fits my data. Now, this is a little wonky because there's a lot of uncertainty in what I just did. So what line fits best? Well, the red line best looks like what's going on. The green line, that makes no sense at all. So I'm going to scroll down a little bit here. You see that the green line represents this formula right here, the green. I can exit out of that to get rid of that green line. The blue line, I can exit out of that to get rid of that blue line. The purple line doesn't match up at all. I can get rid of that to get rid of the purple line. So that leaves me just the red line sliding back and forth. I'm going to just ignore this number right here because it just doesn't make any sense at all. So with this, the next thing you need to do is say, okay, I've done this, Mr. Lee, so how am I going to show you that I did this? Well, there's a thing called the snipping tool. It's this little icon right here. I've got it pinned to my taskbar. It's called the snipping tool. If you want, you can type in the search right here, snipping tool. This is really cool. I use this all the time. There we go, snipping. So I just type in snipping. There's the snipping tool right there. I'm going to open it up. And there it is. Took a little while to open it up. So it opened it up, and I brought up this little thing called snipping tool. And what I want to do is I want to do a new snipping tool. And what I want is I want a picture. I want to copy and paste this graph. So I'm going to click new, and it's going to give me this little icon. My arrow turned into a little crossbar, and I am going to highlight basically everything I want to show my teacher. There you go. So now here's your snipping tool right here. It has copied the page where you want it to use, and you just go up here to edit, copy, and then once I hit copy, I can exit out of it. Nope, I don't want to save it. And I'm going to go back to my Google Doc, and right here where it says insert image of Desmos graph here, I'm just going to highlight all that because I don't want that there. And I'm going to hit Control V, and that's going to paste. There it is. And that shows me that you've done what you needed to do. That's your proof that you got your work done. From there, it says in words, describe what the C value means. What's the mathematical model? Your mathematical model, remember, is in this case, S equals C, which is constant, times D. On the graph, it shows up as, and in the real world, what does it mean? Then you just, basically, for the conclusion, I just want you guys to fill in the blanks. One of the big things that a lot of people get stuck on is right here it says it wants you to predict what it is for 10 megaparsecs away, because right here there's no data for 10 megaparsecs. So how do you figure that out? Well, you can either A, look at the graph and zoom out. So if we go back to the graph, we can zoom all the way out to where 10 is. And if we go straight up from the 10, I believe, yep, if you just click on the line where the 10 intersects it, it'll tell you in that little box before the comma there, it says 10.01. You can move back and forth a little bit until you get it to 10 exactly. So that tells you what the x coordinates, that's your distance. And after the comma it says 2360. That's going to be your speed. Of course, that's for my line. Remember, my line is not your line. You're going to get something completely different. But that's what we're looking for, is how fast would it be going if it was at 10 megaparsecs. And that's how you would answer this question. It'd be traveling that far away from it. Then you would tell me about your confidence. Remember, your confidence for prediction deals with this little chart right here, where first of all, we look and see, is my data kind of around all the other data? Well, you'll be just a little bit off, so you got medium confidence. And does your data all line up perfectly on the line? Is it a little scattered, or is it very scattered? And that'll tell you whether or not you should have a high confidence, medium confidence, or low confidence. And that, boys and girls, is it. You should be able to finish this in class with the substitute. So I will be looking for you guys to, when you're done with the lab, to hit submit. A little submit screen will appear right here. I want you guys to hit submit. And if you don't get done in class, it will be due before the next class. I'll be looking for that by next class. So with that said, I'm sure I'm missing you guys. Love you guys. Take care. Bye now.